All right. Now, we have, I don't know if you got notifications about this, but on our team, in the upcoming quizzes and tests, it's going to be a little bit dark. There we go. Oh, that's Chem 12. That's why it has nothing. You guys are Chem 11. There we go. Upcoming quizzes and tests. So we actually have, hey, where'd the other one go? Did it not get posted? Well, that's irritating. I wonder if it's online. Let's see. Teams. Sign in. Because we're going to have a quiz tomorrow on, I just want to sign in. Sign in. There we go. Come on, wake up. I don't care, switch now, whatever. And Chem 11. Yes. All right, and if you think that I don't know that you're on your phone, if you have it in your lap, then you are sorely mistaken. Get off your phone, okay? Upcoming quizzes and tests. There it is. Now, why is it on this one and it won't show up on the other one? I'm not entirely sure, but we have a quiz on the SI units, the metric prefixes. So in order to review for that, you can finish up, if you didn't finish up page 63, you can finish up page 63 and 64. Now, to be honest with you, what it's going to look like, it's really, really straightforward. If we go to page 63, the quiz will literally look like one of these tables, okay? So it's going to have written on it volume, distance, moles, Kelvin, one of each of those things. Does that make sense? Okay, so one of those will be filled in. You will fill in the rest of them. Okay, so you can practice. Now, I want to let you know about something that I do with my classes because I started doing this during COVID because I don't know what it was like for you, but my classes were very needy and some people could not manage to do anything because we were hybrid. So some people were super bored and some people could not manage to do anything. So what I started doing is I started I label them with a diamond because it's kind of like a black diamond. Like if you've been skiing, black diamond hills are like the harder ones. Yes? So if you choose to do this, I call it enriched content. It's not really that enriched, but it's just kind of things that would be nice if you would either memorize or learn to do, but if you choose not to, it's not the end of the earth. Does that make sense? So if you choose not to do this, it will not count against you. All right? This goes into a separate bin. So it is possible to get 100% in the course without doing any of this. Chances are, if you don't do any of this, you're probably not a 100% student anyway, because you'll probably look at it and go, well, some of that's really easy. Why don't I at least do some of it, right? So this goes in a separate bin, and let's say overall in the course you get 81, no, let's make it 80%, because then I can do the math easily. Okay, so we get 80%. And then let's say on all the enriched assignments, you get 50%, okay, on average, yeah? If that's the case, what I do is at the end of the term, if you got 80%, what I do is I take 3%, that's the maximum possible enriched mark you can get added on to your grade. So if you got 50%, 50%, I would add on 1.5 because 50% of 3 is 1.5. That only happens at the end of the term because it's too much of a pain in the butt to do it like, every 2 weeks or whatever, okay? So it'll happen at the end of term 1 and it'll happen at the end of term 2 or 3 or 4 or whatever they're calling them these days. Is good? Does that make sense? So this little symbol will denote when we have something like that, okay? So if you choose to do the enriched version of this quiz, your quiz will look like this. Yeah? So you just won't have any of the little things written in for you. But if you think you can fill them all in on your own, that's great. All right, and that quiz is happening when? Tomorrow. Can you redo it? Yes. And that one, honest to God, there's like not much to it, so you can redo it as many times as you want to. And when I say as many times as you want to, after about a week and a half, I'm like, okay, we've moved on past that. Don't do it. You cannot redo it anymore. So don't come to me a month from now and be like, can I redo that quiz from the beginning of the year? No, get your act together and get it like done in a reasonable amount of time, okay? Right, so we have that. And the other thing I wanted to add for you is if you want to do the enriched part for the prefixes. Where did those prefixes go? Here they are. The enriched part for the prefixes would involve knowing the powers of 10. Okay? So you would want to know that mega goes with 10 to the 6. Kilo goes with 10 to the 3. Deci goes with 10 to the 1. But these powers of 10 are also enriched. So if you choose not to learn them, you'll learn them in Unit 2 anyway. But if you want to learn them early and do it as an enriched little thing, you can. Would you like to learn the song that goes along with the powers of 10? I don't care, I'm going to teach it to you anyway, okay? So hopefully you're okay with learning that. Now let's remind ourselves of our little song, okay? So we'll start with mega. Oh, I need a highlighter. Highlighter, there we go. Okay. Mega, kilo, deci, centi, milli, micro, nano. Mega, kilo, deci, centi, milli, micro, nano. Mega, kilo, deci, centi, milli, micro, nano. 6, 3, 1, 2, 3, 6. 9 is for the nano. You see how I added that little bit in there? Okay, so here's how it goes with the new part. Okay? Mega, kilo, deci, centi, milli, micro, nano. That's the same as before. And then we just stay on the same note for the next few things. And then we go 6, 3, 1, 2, 3, 6. 9 is for the nano. So it goes 6, 3, 1, 2, 3, 6. You don't even have to learn any new notes, like really, because it's all the same note. Yeah, 6, 3, 1, 2, 3, 6. And then 9 is for the nano. Now, mega, kilo, deci, centi, milli, micro, nano. 6, 3, 1, 2, 3, 6. 9 is for the nano. Now, let's just, before we carry on with that, We need to know which of these are positive and which are negative. Do you guys know which ones are positive? The first two, these are the big ones. And these are the small ones. So these are all more than 1. And these are all less than 1. Those are all fractional, okay? And what you'll notice actually is that a lot of them are powers of multiples of 3. That's because science very often works in powers of 3. In fact, if you go down past nano, there's pico, which is 10 to the negative 12, and femto, which is 10 to the negative 15. And you guys probably actually know the one that is 10 to the positive 9 is giga, but we're not going to need that for chemistry because we don't usually go very big, okay? So our positive exponents are up here, and our negative exponents are all down here. So what it's going to look like, it's going to look like 10 to the 6, 10 to the 3, and then all of these ones are negative exponents. So 10 to the negative 1, 10 to the negative 2, 10 to the negative 3, 10 to the negative 6, and 10 to the negative 9. Okay? And if you forget the song and you're like, oh, hang on, what's happening? I need to know the song. It will be on the video at, does it tell me how much time I've been recording? 11 minutes and 41 seconds. Okay, so it's at 11 minutes and 41 seconds. We're going to sing it one more time. Okay. Mega, kilo, deci, centi, milli, micro, nano, 6, 3, 1, 2, 3, 6, 9 is for the nano. Mega, kilo, deci, centi, milli, micro, nano, 6, 3, 1, 2, 3, 6, 9 is for the nano. Okay? So you can always put that up on play if you want to. And that is it for that. Did we all watch the accuracy and precision videos? Could you please tell your neighbors what the difference is between accuracy and precision? Please describe to them what is accuracy and what is precision.
You didn't watch it. Well, accuracy is how you true value. Precision is on how close the series of values are to each other. It's over.
Okay. Anyone want to tell me what accuracy is? Yes, Rajan. Yeah, how close you are to the actual value. Isn't it nice that accurate and actual both start with ac? Okay. How close to the actual value? So we have an ac and we have an ac. Now, if we only have one measurement, that would work quite nicely. What if we had several measurements? What would we have to do first? See if you can tell your partner, if we have several measurements, like if everybody in the class had a different balance, and I gave you all a rock, and you had to pass the rock along, and you put it on your balance and you measured it, and you put it on your balance and you measured it, and you put it on your balance and you measured it. What would we have to do with all that data before we could figure out the accuracy of the measurements? And if you don't have any paper and you're thinking, man, I would like to write this down, where could you go to find yourself some paper? Just at the back of the room, there's a little green bin back there and it says free blank paper. Or you can write it on the inside cover of your book or whatever. Vocabulary. There's quite a lot of vocabulary in this unit. So actually on our team, not that one, where is Teams? There is Teams. I have added a new channel, and this one says vocab lists by unit. And you'll notice that the first two words on there, probably, I don't know if you can read them, it's too small probably, but they are accurate and precise. And today we're going to, if you haven't already learned about it, we're going to learn about the word calibration. All right, so 2 days in, and we already have 9 words that you need to know the meaning of. Okay? Now, when I say you need to know the meaning, usually I don't mean that you have to define it. Although maybe for accuracy and precision, I could do that. Usually what I mean, to know what it means, I will ask you questions that require you to know what they mean in order to answer them. Does that make sense? It's not going to be like, please spit out a memorized definition of blah. It will ask you something like, please draw me a target where I have, is this not going to scroll for me? Come on, there we go. High accuracy, but low precision. And let's say I gave you the target. And just in case you're wondering what this little thing is, my pen just does that. I draw a circle and it just does that. So I'll just erase it and do it again, and hopefully it won't do it the second time. No, it didn't. I'm going to stop explaining that my pen just does that, but it is irritating, and you'll see me like go, yeah. So if this is a bullseye, and we needed to have high accuracy and high precision, I could ask you to draw, let's just say, 4 X's that show high accuracy and low precision. We'll come back to that in a moment after we've defined precision, okay? But that's the kind of question I could ask that's not a definition, but requires you to know what it means, okay? So, if I have a set of measurements, do you remember like Tyler said, oh, please estimate my age, right? And everybody estimated the age. What would you need to do before you can judge the accuracy of that set of guesses? Pardon me? You would need to, sorry, I'm going to get you to repeat that because I don't think I heard you properly. Sorry? You have to know the actual age. That's the first thing. So we have to know the actual value, but there's something else we need to do specifically if we have more than one measurement. Have a chat with your partner, see if you can remember what it was. We need to take the average. So if we have a set of measurements, in other words, more than one measurement, we would need to take the average. Ooh, guess what? Average starts with the letter A, which is also how actual and accurate start. So that might help you remember that when you're finding the accuracy, you need to take the average. Do you remember how to take an average? Anyone need a review on how to take an average? Add up all the numbers and then divide by... How many people think they know how to take an average? I won't call on you. Okay, I think probably most of you know, but just in case, it may have been a while, add up all the measurements and divide by the number of measurements. Is good? Okay. Oh, what happened? Where did it go? It jumped. There we go. All right. So that is accuracy. You have to take the average if you have more than one measurement, and you're comparing it to the actual value. Precision. Anyone want to define precision for me? Yes? Yeah, so for precision, you need to have several values and they all have to be consistent with each other. So it's how close a series of measurements are to each other. So again, it's how close. And in this case, it's a set of measurements are to each other. So accuracy was how close it is to the actual value. Precision is how close they are to each other. Another way of thinking about it is the repeatability of the measurement. If you can repeat the measurement and get the same value or very close to the same value over and over again, it is very precise. Now I got really excited about the repeatability of a measurement, because guess what is in the word precise? A precise measurement is very repeatable. Is good? Okay. And now you guys are going to try and draw on this bullseye here. And we're aiming for the center of the target, okay? I would like you to try and draw 4 X's that would show high accuracy but low precision. High accuracy but low precision. So just draw yourself, and if you don't want to draw like the whole target, you can just draw the circle and put a dot in the middle, okay? See if you can draw high accuracy and low precision. And once you've drawn it, compare it with the people sitting near you. And if you haven't drawn it, then you need to get out a pen and draw it, because you don't learn anything by not doing it. Low precision, high accuracy. Yep. I think I gave you guys the hardest one to start with. I should have given you the other ones. Should we start with the other ones? Let's start with high accuracy and high precision. Let's start with that one. High accuracy and high precision. That one's much easier. Okay, where should they be? If it's highly precise, should they be close to each other or far from each other? They should be close to each other. And if they are highly accurate, what should they be close to? Close to the bullseye. So if I was to put them like here, 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 would that be pretty good? Those are pretty close. They're close to each other. They're close to the target. That's high precision, high accuracy. Let's try low accuracy, high precision. Because I think that this one is the easiest.
Oh, Miss Best guy used to walk.
Absolutely, yeah. Low accuracy, high precision. If they're low accuracy, what can we say about them? They are far from what? The bullseye. But if they are high precision, what are they? They are close together. So could I put them up here? Would that be okay? Are they close together? And are they far from the target? Yes. Could I put them here? Yes. Okay. Either this, or as long as they're close together and anywhere far apart, it doesn't really matter. Now we get into the trickier ones where we have some low precision. Okay, so over here, we're going to try low accuracy and low precision. What does it mean if there is low accuracy? Now, remember with the accuracy, if there's more than one thing, what do you need to think about? We have more than one point. Therefore, do you guys know the little 3 dots for therefore? Okay, that means therefore, if you haven't seen that already, therefore. If we have more than one point, what do we have to think about? We have to think about the average. So we need the average to be far from the bullseye. So here's a question for you. Would it be okay if I did this? Would that be, is that low precision? Let's start with precision. Is that low precision? Yes. Is it low accuracy? Where is the average of these 4 points? Right in the center. Because if we average the left to right distance, the average of the left to right distance is here. If we average the up and down distance, the average of the up and down distance is here. And so the average would be right in the center. So this would be wrong. Okay, because it would be low precision, but high accuracy. Okay, so what we would have to do in order to get low precision and low accuracy is we'll have to make the average somewhere other than the middle. So I could do that by having my 4 points sort of far from each other, but all kind of hanging out on the left. Yeah? Because the average of those points, I would say, is probably about here. Yeah, ish. So it's not, I mean, I could even be less accurate by moving one over to here, and then my average would be about here. Yeah. Okay, so you have to think about that and think about where your average is going to be. Are we feeling okay about that? All right. Quiz on the average accuracy and precision on Friday. Okay?
We did the accurate but not precise one, okay.
Oh, accurate but not precise. Let's do that. This is accurate, high accuracy, low precision would be what if I needed to do What if I didn't want them to look exactly like that? I could also go like this and be does that work? Because the center is also at the center. Yeah? What if I needed to do 3 points? How could I do it with 3 points? I can make a triangle, okay? And I could be like, okay, here I go. 1, 2, 3. I could also make an isosceles triangle. See, look at that funny little circle thing there. Okay. But that one's trickier because I've got 2 points that are further down. No, just forget I did that one. Just don't look at that one. I'm just going to erase it. I made a mess. Let's get rid of that. There we go. Okay. Is good? Okay. Have you met the word calibration yet? Calibration? No. Okay. Calibration is a procedure that we do when we have a measuring device. So when they make this ruler in the ruler factory, they have to have something that is exactly a meter long so that they know that this is actually a meter. Okay? So they will have something that has been calibrated really precisely in order to make this. If you don't calibrate it and you make your meter stick, say, only that long, it's not going to be very good, right? And each centimeter would be much smaller than it would otherwise be. So calibration is when, let's say you put your scale on the counter and you press the 0 button and it reads 3 grams and you have nothing on it. Has that been calibrated well? No, you would have to, there's certain buttons you can press on the electronic balances to calibrate them, okay? So calibration, let's go here. There we go. So accuracy, we have all the definitions here. This is on page 38. Page 38. So we have an actual definition of accuracy, precision, and then calibration, a process done on a measuring device in order to ensure its accuracy. For example, many balances have a mode in which you put on a 100-gram mass, and then you press a button and it says, this mass is 100 grams, and it will set it based upon that. Okay? All right. That's it for accuracy and precision for today. You have a quiz on this on Friday. Okay? So part of your homework tonight will be to do this second accuracy and precision thing in order to review for yourself. Yes? Okay. And today, the next thing we are doing is not that. Why do I keep clicking on those things? 1.6a. We're going to be looking at exponents today. So this is page 105. And if you think, wow, this lady is crazy, she just jumps all over the book, there is method behind my madness. One of the study techniques that works really well is called spaced repetition. So if you learn something one day and you never hear about it again, then you have a tendency to forget about it. But if you hear about something one day and then you hear about it the next day or 2 days from then, you have a much better chance of remembering it. So that's why you watched the video on accuracy and precision yesterday, and we reviewed it together today. Today, we're going to learn about some exponents And then we're going to do something with those exponents later in the week so that you keep hearing these same concepts over and over so you don't tend to forget them. All right. Are you all familiar with how positive exponents work? Positive exponents? So if I was to say to you, and these are all written here for you, but I'm just going to put them over on the side here. If I was to say to you 2 squared, what does 2 squared mean? That means 2 times 2. So you have 2 twice. And that would equal 4. All right. And then if we had, what if I had 2 meters squared? What does that mean? It means I have 2 meters times meters. Okay. Now there's no way of reducing this back to anything. So we would just have to go back to 2 meters squared. What if I had 2 meters in brackets squared? Everything inside the brackets is squared. So when we have a squared and there's no brackets, it only refers to the one thing that it's attached to. But when we have a square and there are brackets, it refers to everything inside the brackets. So it means we're squaring the 2 and we are squaring the meters. So we will have 2 times 2, because we've squared the 2, and we will have meters times meters. And eventually, if we finish that up, 2 times 2 is 4, and then meters times meters, we would just end up back at meters squared. Okay? Now, what if I had 2 squared over 3? I would only square the 2 because the 2, the little squared is only attached to the 2. So I would have 2 times 2 divided by 3. And I would get 4 over 3. But if I had 2 over 3 squared in brackets, now the 2 refers to both the things in the brackets. So we would have 2 times 2 over 3 times 3. Is good? Okay. Let's see. Oh, I forgot. What if we have a negative in front of a number? What if we had negative 3 raised to the power of 2? Now, I don't have brackets here. Okay, so there's no brackets. So once again, the 2 only applies to the 3 and not to the negative sign. So that's going to be, I've got my negative sign and it does not get squared because the 2 isn't on it. There's no brackets. 3 times 3. So that's going to equal negative 9. It's different, though, if we have negative 3 squared. Yes? Because now we're squaring the negative sign and the 3. So that's going to equal negative 3 times negative 3. And what do you get if you have a negative times a negative? You get a positive, so you're going to get positive 9. Okay? And I know you're like, what are we doing with exponents in chemistry? What does this have to do with chemicals? It has to do with the fact that we are going to be using scientific notation, like we had that number yesterday, 6.02 times 10 to the 23. Plus, we're going to be doing some calculations with formulas where we have units that are squared or cubed. Okay, and sometimes they're going to be on the top, sometimes they're going to be on the bottom, sometimes they're positive, and sometimes they are negative. Do you guys want to take 10 minutes to do these questions here and see how you can do with them? And if you get finished, don't worry about the exponent rule. I got a little excited last year and I put it in here and I would have gotten rid of it, but I had leftover workbooks from last year. So just worry about writing the expanded form and the standard form. If you finish, you can try the next page if you finish. I'll come around and help you out if you get stuck. Wave me over if you get stuck. Yes. No, you don't. You could write the extension. That either way works. You could write 10 separation. Okay. But either way works. Not in brackets. Shift cube. Yeah, exactly. You just write centimeter squared again. There's nothing else you can do. You can do it either way, to be honest. Yeah, it works the same. So you could either do 2 times 2 times 3 times 3, or you can do 3 times 3 times 3 times 3, or you can do 6 times 6. Honestly, I'm not going to be testing you on the exponents specifically. This is just getting you warmed up with them. It's been a while, so you've done now. Well, pretty much squared same as one. But yes, other than that, yes. Oh, yeah, so this would be for possible. Yeah. Yes. Yeah. Oh, really? Yeah. Yeah. We'll get to that in just a moment, okay? So if you're finished, I'm actually going to just quickly do negative exponents with you because some people are getting there. Don't worry if you're not finished positives, you can go back to those. But yeah, let's take a look at negative exponents for a moment. So that would be on page 106. So the first thing that we need to know, we're going to do, this is page 106. If I can get my pen working. There we go. Anything raised to the 0 power, we're going to start with 0 rather than negative because it's the easiest. Anything raised to the 0 is equal to 1. So if I have 47 raised to the 0, what's that? 1. If I have 8/3 raised to the 0, that is 1. Okay, so that's a nice easy rule. Anything to the 0 is 1. Now, if I have a negative exponent, I can turn it into a positive exponent by flipping it upside down. Okay? So anytime I have a negative exponent, I flip it and I make the exponent positive. Okay? So what that's going to look like is, where is it? There we go. Let's say we had, for example, and these examples are in your book, so you don't have to write them down. If we have 2 to the negative 1, we're going to flip that upside down. So we're going to put the 2 in the denominator instead of in the numerator. And we're going to change our sign from negative to positive. So now it is 2 to the positive 1. But we won't actually write positive 1. We would just write 1 over 2 to the 1. Okay, we don't have to write the positive there. So that would be equal to 1 over 2. We can do the same thing with a unit. Seconds to the negative 1. Well, if I have a negative exponent, I can take the reciprocal, 1 over seconds, and raise it to the positive 1. So that just becomes 1 over seconds. What if we had minutes to the negative 2? Well, minutes right now is in the numerator. I know there's not really a numerator and denominator here, but you could always put that over 1 if you wanted to, yes? Okay, so we're going to now take the reciprocal. So we're going to put minutes on the bottom instead of on the top, and it's going to be raised to the power of 2. So that would then become 1 over minutes times minutes. And then we would just have to write it as 1 over minutes squared. We don't have any choice. What if we had six times 3 to the negative 2? Does the 6 get hit by the exponent? No, the negative 2 only applies to the 3. So what we will have is we'll have 6 times, and then we're going to take the reciprocal of the 3. So that's going to be 1 over 3, and then we'll make it positive because we've taken the reciprocal. So that's going to be 6 times 1 over 3 times 3. Or if you prefer, you could write it as 6 over 3 times 3. Either of those is okay. Yeah? There's many different ways of showing this, and if you understand what's going on, don't get too wound up about how to show it. I'm never actually going to do any sort of testing or quizzing of you on just this mucking about with exponents. Okay, it's just to remind you of how the rules work before we get into some more sophisticated stuff. Okay, so then we would have equals 6 over 9, which is equal to 2 over 3. Hooray, there we're done. Okay. Now, what if we had 3 times 2 to the negative 1. Ooh, but then what if we put brackets on the outside and we had a cubed there? Yes. Yeah, it's going to be 3 over 2. Beautiful. Okay, because the 2 is now moved into the basement. It is raised to the power of 1, but you don't have to do anything with that. And then the cube still stays on the outside. And so then that would be 3 times 3 times 3 over 2 times 2 times 2, which would be 27 over 8. That's not a nice number, is it? Okay, so give pages 105 and 106 a try. If you finish that, you can also do page 107. Okay, so your homework is pages 105 to 107. And the accuracy and precision one as well. Where did it go? 30 something, 38. Yeah, 38 and 39. And you're going to study for your quiz. House is over at what, 44? Okay. Yes. That's correct. Yeah, that's all we need. Yeah. Okay. Yes. So anything that has a positive exponent stays in the numerator. Anything that has a negative exponent can just move down to the denominator. Okay? Yeah. Yeah. Oh my gosh, that's a typo. Thank you. Folks, there's a typo on page 107. My apologies for that. On page 107, where is it? Oh, you know what? I might have fixed it. I think I might have fixed it in the new version, but it's not fixed in the old version. Let's see. 107. Oh. Yeah, if yours, I think I managed to correct it if you have like an updated booklet. But number 33 for some of you might say 10 to the negative 5, but it should say 10 to the negative 1. This is on page 107. Number 33. If it says 10 to the negative 1, you're okay. If it says 10 to the negative 5, just change it to 10 to the negative 1. And if you're wondering why there's errors in this book, it's because I made them. So. Yeah. Yes, certainly. Would you also be okay to watch a 5-minute video? Yes, you would. I'm going to add pages 43 and 44. Is that too much? No, it's not too much. Fill in the blanks. One, two, three, four. There we go. Did everyone catch? I added something onto the homework because I'm a horrible person. There's video on pages 43 and 44. You're going to watch it and fill in the blanks. 5 minutes. So it shouldn't be too bad. Okay? So you're like, I'm good. So yeah. Problem is when you haven't had like a whole year. I know that's that's why we do this. I'm like, I don't know whether you had it like yesterday or a year ago. Yeah. Oh, no, that's not going to work. Okay.
Please go to the bathroom.
Of course. It takes a while. Well, I'm going oh, yeah. All in a row. Yeah, that's not. I'm like, okay. They're all fine with that. That is like fine. So yeah, okay. Yeah. That's, oh yeah. I think those are the trickiest ones. What's what it means? Find really something to zero out that means that it's equal to one. I'm sort of over asking for zero to three. It's just 18 times now. Like if there's no 18, you don't put anything. It's just one. Yeah, just one. Nothing to say here. I love it. Well, I'm actually
Sorry for the interruption. This is just a quick announcement for all grade 11 to please make sure to watch your email this week for the CLC 11 assignment. It will be coming to you via email at some point this week.
Oh, yes, I am charged you 50%.
This is a reminder for grades 11 and 12 students that the winter formal has been rescheduled for the end of the month. And tickets are still available for public practice.
Oh, yeah. Well, it's fine.
Bye. Okay,
With like my dance company.
okay.
So do I just look on Teams?
You can just look on Teams, and remember, if you want to watch the lesson, the video will be posted.
Okay.
Okay, and if you don't want to watch it, you can just like read about what we did in the homework section. It'll say homework, and then it'll say what we did in class.
Okay.
Okay? Yeah,
I guess Thursday at flex my quiz.
absolutely. Yep. Bye.